Hey, welcome back to Math with Patrick. Today is February 26th, and we are solving problem number 57 together from this Daily Epsilon calendar with Quill today. He really wants to join in. There he is. And he'll just be helping out with moral support today. Alrighty, so, we have a function. That's what this F here stands for. And this function is going to input positive real numbers and output any real number. And so that's what this notation here means. Essentially, I'm going to be inputting maybe the number 1 or the number 10 or pi or 0.0001, just nothing negative and also not 0. And apparently the output is any real number you want. And I have this rule where if I input t over 4, I get all of this. Something interesting is I noticed that within the function itself exists the function. It's kind of like the whole snake eating its tail thing, where it's like it's referencing itself in the function. That's a little bit weird. So I'll have to deal with that. And then ultimately, once we figure out how to plug things into this function, we should just plug in 7, and then we'll get our answer, which should be 26, today's date. So my plan here is I'd really like to be able to rewrite this as just f of x equals, and then the rest of the stuff in terms of x. And ideally, I don't have another like f of x in here, because I don't want to like plug something in and then have to plug something in back into itself, which will make me plug it. So you kind of see what I'm saying here, where ideally I only have x's on the right side, or I guess t maybe, because the input variable could be t here. Well, okay, why not? Let's just change it to x. So you could just substitute x equals t over 4. And that way you can get f of x. Well, hold on. We already have x as our answer, and I don't want to double up with a variable. So let me call this like a, I guess. And then that is going to be equal to 3 times f of, 4 over t, but t is, here, let me do some algebra here. T is going to be the same thing as 4 times a. I'm just multiplying both sides by 4 right here. So I could replace this t in the denominator with a 4a. All right. And then minus 7t. But again, I'm like trying to replace all my t's with a's, so I could put like a 4a right here. And maybe I could simplify this. 4 divided by 4 is just going to be 1. And so I have like a 1 over a in here. And maybe the 7 times the 4 could be a 28. Okay, well, I mean, I still have this problem where when I plug in some number a, I still have the function in the function. So maybe I could try taking this part out and renaming that. So, okay, let's see what happens if I plug in a 1 over a into my function. So let's see, well, f of a, here I'll just rewrite what we have already, is 3 times f of 1 over a minus 28a. And then if I instead replace this a with a 1 over a, just kind of the rules of function notation say that every time I see another a, it should be a 1 over a. And so every time I see an a, it should be a 1 over a. And so now I have some kind of expression that is the same as f of 1 over a. And I'm noticing something good here, where if we analyze what's happening to the input here, we have 1 divided by 1 over a. And maybe the quickest way to unravel this is you could think of fraction division as keep, change to times, and then flip. So anytime you have division and then a fraction, you can keep the first number the same, change it to multiplication, find the reciprocal or the flip of the last fraction. And 1 times a divided by 1, all of this is just the number or the variable a. And finally, I guess I could simplify this last part where 28 times 1 over a is just going to be 28 divided by a. And there we go. This is actually really cool because now I have f of a equals 3 times all of this stuff from this expression, because it's the same as f of 1 over a. So 3 f of a minus 28 over a. And then I still need to do that minus 28a from this part here. And how about I'll distribute my 3. So this is equal to 9 times f of a minus whatever 3 times 28 is. That's 84 over a. I distributed this 3. Still have this minus 28a at the end. This is all still equal to f of a. And I still have this problem where if I plug in an a, I need to reference the same function again, and I'm kind of in this infinite loop. Except we can do some algebra steps. If you pretend that this is just like kind of some like y variable instead of a function, it kind of works the same, where if you wanted to combine like terms, we could like subtract a 9y from both sides and get these to combine together. And so the same thing is going to work here with the function, where I could do f of a minus 9 times f of a is still going to be equal to this whatever's left on the right side here. And I can do some factoring here. If I have f of a minus 9 f of a, or one function minus 9 of itself, that's like saying 1 minus 9 times the function. Or in other words, we have negative 8 times the function. And then finally, I can actually isolate my function. F of a is going to be the same as this side over here, which was negative 84 over a minus 28a divided by negative 8. And so here is actually my goal. It's like what I wanted to do was isolate this function all by itself. I'm going to center it a little bit more here. And now on this side, I don't have f of a or the function itself at all anymore. I can just plug in a number, do some arithmetic, and get an answer. Let me simplify it a little bit first. I noticed that I could cancel all these negatives. I can negate the top and negate the bottom. I don't change the value of my fraction. And then they're all even numbers, so I could have them all. So like maybe there's a 4, a 14, and then a 42. And it looks like I can do that again, where I get a 21, a 7, and then a 2. And then I can't divide anything by a common factor any further because 7 and 2 and 21 don't share anything in common. So this is as simple as I think I can get my function. And it looks like if I plug in a 7, I should get 26. If I do, I'm done. So let's try it out. F of 7 equals 21 over 7 plus 7 times 7 divided by 2. That is 3 plus 49 divided by 2, which is 52 divided by 2, which is today's date, 26. Wow, this was honestly a really unique problem. I haven't really ever done this like unraveling of like dealing with functions, especially when their inputs were different. I think I got kind of lucky where I found some cancellations to get another f of a out of all of this. And ultimately that helped me isolate just the function. I could plug in 7 and I got 26. So there's my solution. Thanks for coming along. I'll see you tomorrow. Bye.